the title of my poster is The Efficient and Economical Method for the Production of Monodisperse Phase Changeable Nanodroplets. So first I'll go into a brief introduction of what nanodroplets are. They are closely related to microbubbles, which are considered the original ultrasound contrast agent. They're used in a variety of clinical applications, they have FDA approval, and they are made of a lipid shell and a gas core. But they are limited to the vasculature and they have relatively short circulation times. So this is where the nanodroplets come into play. They can overcome these limitations because they have a lipid shell and a liquid core and a smaller size, and this allows them to move out of the vasculature into tissue, and it also gives them a much longer circulation time. Additionally, droplets are able to transform back into a microbubble by vaporizing their liquid core after it is exposed to heat or an acoustic field. And this transformation, it is dependent on the vaporization threshold, and that threshold is directly dependent on the size of the nanodroplet. So for this reason, it is desirable to have a monodisperse population of these droplets. But that's easier said than done. Many methods are out there to create nanodroplets, however, most of them result in a polydispersed population, and if they don't, then they're probably complex or a little costly. So that brings us into the goal of this project, which is the development of a method for the formation of monodisperse phase changeable nanodroplets, but one that is economic as well as efficient, and this was done with extrusion and a pre-formed microbubble solution. So the extruder is assembled with a 200 nanometer filter, and it is placed in an ice bath. That pre-formed microbubble solution is pre-cooled at negative 15 degrees Celsius for 2 minutes, immediately put into the extruder chamber, and immediately 250 psi is applied. This pushes the solution through the filter and out of the extruder. As it goes through that filter, the microbubbles are compressed down into nanodroplets. So that solution that is collected is then ideally the monodisperse solution. Looking into the results section, if you take a look at figure 3 specifically, section B and D, you can see there's much more microbubbles here than compared to A and C. So this implies that after vaporization, these microbubbles that we see here actually came from vaporized droplets that were originally in the solution we collected. So in A and C, they're nanodroplets, then we apply heat, and then we get these microbubbles. So that implies that we did indeed successfully condense those microbubbles originally. When it comes to the monodispersity of the solution, you can look at the next two charts on here. Figure 4 specifically includes a comparison to a condensation method, which is known to have a polydisperse distribution. You can see by looking at the curves, the extrusion curve has a less of a range, and so it is more monodisperse. Again, in figure 5, there isn't a comparison here, but you can see that it isn't a very broad range. We have more of a somewhat monodisperse solution where we don't have super big droplets and super small ones at the same time. They're more localized around a single size. Additionally, you have to take it a little bit with a grain of salt in terms of the microscopy, specifically with the OFP after vaporization, which is D, because we see a lot of coalescing immediately after, which is why the distribution is done before vaporization happens, before those bubbles coalesce. So in conclusion, this method does create a nanodroplet solution that is relatively monodisperse. In terms of future directions for this method, the pre-cooling is the biggest aspect that can be improved on. Potentially having a coolant system instead of an ice bath, or instead of having a sudden 2 minutes of really cold pre-cooling, maybe having that solution be cold for a little bit longer, more of a characteristic instead of a sudden change. Both of these could potentially increase the efficiency of the condensation. But besides that, that is the method for producing these droplets.